So for example, I guess we did do this one, right? Yeah, I think we did this one. Let's do if 40 dm cube kc this one. Maybe this was say khatam ho gaya yahan pe. So we did this question earlier as well. Because all these questions were kind of very similar, so I'll just do one very quickly. Okay, that was a question could be different. So you can try and do this one. So these are the initial moles that are given, and they've told us that the value of Kc is they've already given us the value of Kc. That's given over here. That's 6.4 times 10 raised to the power minus 1. That's already given. So we have no idea what happens. That you add the initial moles, you mix them together. So how many moles react? I have no idea. So I'm just going to assume that X moles of carbon monoxide, they react out of the 0.4 moles that you've added. So it's 1:1. So X moles of water will also react. And everything is 1:1. So दूसरी side पे ना, the carbon dioxide, there's going to be X moles that will be produced, right? And X moles of this thing will also get produced. So your moles at equilibrium will be 0.4 minus X. This will be 0.4. Now X have reacted, so it's 0.4 minus X. Or यहाँ पे it's going to be 0.2. But now there's an extra X moles that have been produced. Now it's going to be 0.2, and there's an extra X moles that have been produced. So these are your equilibrium moles now. And you don't need to, I mean, although it's a 1 dm cube container, so the concentration would be exactly the same mole per dm cube. But you don't even need concentration in this case. You can use moles directly. Your Kc expression will be product concentration. So it's going to be 0.2 plus X times 0.2 plus X. That's 0.2 plus X squared. And it's going to be divided by the reactant concentration, 0.4 minus X times 0.4 minus X. And that's going to be squared. We already know what the value is. That's 6.5. Sorry, that's 6.40 times 10 power minus 1. So that's 0.64, I think. The value is 0.64. And you can try and solve this. It's going to be what? You'll unroot this. So the square will go away, and it's going to be 0.2 plus X is equal to 0.64 under root, and that's multiplied by 0.4, and minus 0.64 under root multiplied by X. If you bring all the X together, that's going to be X plus 0.64 under root X on the left side. And if I take everything else to the other side, it's going to be 0.64 under root times 0.4 minus 0.2. And your X will be divided, I mean, this thing will get divided by 1 plus 0.64 under root. So that is going to be your value of X. That's the first value of X. And you'll have a second value of X as well, where this thing will have two values. It's going to be plus or minus. So the other expression for X will be that it's going to be minus 0.64 under root times 0.4 minus 0.2. And the whole thing gets divided by 1 minus 0.64 under root. So without dono x की values, what do you get for both these values? क्या आएगा हुनैद? Ahmed, Rafi? Quickly, what are you getting for this?
So the first one is 0.067.
First one is 0.067.
Yep.
And it's TK 2 significant figures because everything is What about the other one?
Negative 2.6.
So that's negative 2.6. So you're getting two values, right?
Hmm.
So you're going to substitute. These are your equilibrium. Anyways, that's your equilibrium moles. So which value will not give negative moles? Moles cannot be negative. So I guess you're not going to use minus 2.6 because if you use that, it's going to be negative moles. You're going to use 0.067 and you're going to substitute them. So सारे moles आ जाएंगे, ठीक है, you'll get your answer. Is that clear?
जी सर.
Yes.
So remember two types of questions. That's the second type of questions. The first type was you're going to get two types of questions. Kc given, find the equilibrium moles. And the first type of question was you find the equilibrium moles and then you find Kc. So mainly it's two types of questions, which are these. So now what we're going to do is we're going to move on. Okay, we're done with Kc. Remember, all equilibrium constants, they only change with one thing, and that is temperature. Otherwise, they're all constants. Now what we're going to do is we're going to do Kp, which is no different. Kp is exactly the same. It's proportional to Kc. And Kp is used for, normally it's used for gases. So normally use it for gases. Why? Because the concentration of a gas and the pressure of a gas are proportional. Pressure is proportional to concentration, but this thing is only true for gases, only for gases. Normally you don't use the word concentration for gases. If you've got a container and that container has all these, it has all these gas particles. Those gas particles are going to bump into the walls of the container. They're going to exert pressure equally on all sides. You increase the concentration, the pressure will also increase because the number of collisions will be a lot more. So जितने ज़्यादा particles होंगे, more particles per unit volume, more concentration, you'll have more pressure being exerted. Is that clear? Okay, pressure is proportional to concentration. Is this clear?
जी सर.
Yes.
Just so that means the same expression for gases. Remember, this is only for gases. If I've got a reaction and I've got N2 reacting with H2 in equilibrium with, it's in equilibrium with 2NH3 and all of them are gases. Now my Kc expression used to be that it would be product concentration divided by reactant concentration. So that was what Kc was. It was the concentration of the products divided by the concentration of the reactant, and the coefficient would become the power. Now Kp is going to be exactly the same, except that you wouldn't be using concentration. What you'll instead be using is the pressure of the products, or the pressure that's exerted by the products divided by the pressure that's exerted by the reactants. Since concentration and pressure are directly proportional. So आपका जो expression in this case, your Kc expression used to be this thing. It used to be NH3 concentration squared. Concentration के लिए you would use a square bracket, and it would be divided by the concentration of N2 and the concentration of H2, and that's going to be cubed. So for Kp, you're going to use exactly the same expression. It will be the pressure of NH3 that's going to be squared and it will be divided by the pressure of N2 times the pressure of H2, and that's going to be cubed. Okay, so it's kind of the same expression. Everything is exactly the same. I mean, they're both proportional to each other. Okay, so they kind of they're kind of exactly the same, except instead of using concentration, you're now using pressure. That's it. Okay, is that clear?
Yes, sir.
Yes.
Okay. So that's it. That's it. You use pressure. The unit would change as well because for Kc you use concentration, right? So in this case, the unit will be if I look for the unit in this case will be concentration squared divided by concentration cubed. So it's going to be concentration to the power -2. So it's going to be mole -2, and dm will be 6. For pressure, the unit is obviously pressure. It's going to be, what is going to be the unit? It's going to be either, now there are three possibilities. You can either use pascals, Pascal squared, and it's going to be divided by pascals multiplied by pascals cubed. And this will come out to be what? Pascals -2. Or you can use kilopascals. Or even atmospheres. It's going to be atmosphere -2. So these are the three units that are used for measuring pressure. It's either pascals, kilopascals, or atm -2. Now you don't have to do any conversion. Agar wo question pascals mein, just solve it in pascals. If it's in kilopascals, just solve it in kilopascals. If everything is in atmospheres, keep solving everything in atmospheres. TK, you don't have to do any sort of conversion. TK, is that clear as well? Okay, the conversion will be kind of unnecessary.
Okay.
Yes.
So now the other thing is, how do you convert concentration to pressure? How do you find out pressure? So let's say N2 or H2 kana, I've got this container, and it's got shuru mein na, initially what I did was I added some N2. These red wale particles है ना, these are ये ढेर सारे कर लेते हैं, ठीक है? So I added N2 particles. अच्छा, और फिर I also added some चलो change कर लेते हैं. So I also added some H2 particles. So these yellow ones, these are my H2 particles into the container. So there are lots of H2 particles that have actually mixed. Okay, now what will happen is, so remember the yellow ones are either वो key बना लेते हैं, the yellow ones and the red ones. Okay. So that's my yellow, that's my red molecule. The yellow molecule is what? It's क्या था, H2, and the red one is N2. So initially I mix them together. Now obviously there's going to be a reaction that will start. One N2 will combine with 3H2. I mean, what does the equation tell you? The equation tells you that एक N2 3 H2 के साथ it reacts and it produces 2 molecules of ammonia. So what's going to happen is that these 1 N2 will combine with 3 H2 molecules, and when they combine, they're going to produce 2 NH3 molecules. So these three react, old bonds are broken, new bonds are formed, and 2 molecules of NH3 get produced. So NH3 का कोई और color कर लेते हैं. Let's say NH3 is green in color. So 2 molecules, just 2 molecules of NH3 get produced, and there's another one. Is that clear? तो ऐसा क्या हो रहा है कि NH3 की जो quantity है, that is increasing, right?
Yes, sir.
And the reaction will continue. Maybe there's another 1 and 2 goes and combines with, so it goes and combines with 3 NH3 molecules, and they turn into 2 NH3 molecules, right? And there would come a point when equilibrium will be reached. Maybe ये भी आपस में react कर सकते हैं, ठीक है? 1 and 2, they go away and 2 NH3 molecules get produced. But there would come a point when equilibrium will be reached. Equilibrium will be reached. That means just speed NH3 form or NH3 will be it will start decomposing back again as well. So next time this happens, the net quantity would remain the same, because if 2 and 2 NH3 molecules get produced at the same time, the reverse reaction will also happen, and N2 and H2 will get produced back again as well. So that is the point when equilibrium will get established. Is that clear? Okay. There would come a point when the concentrations of the H2 and N2 and NH3 will stop changing. Is that clear?
Yes, sir.
Yes.
Okay, when this is clear, clear. So there would come a point when it will stop changing altogether. Now, how do you calculate pressure? Now, concentration is easy. Concentration was easy. Like if they told us that it's a 1 dm cube container, I would know, okay, for example, if this is a 1 dm cube container, I can calculate the concentration. I can just find out the moles of NH3 and divide by the volume. I can find the moles of N2 and divide by the volume. I can find the moles of H2 and divide by the volume. How do you calculate pressure? Now, pressure is, okay, the entire container is going to have a pressure. You're going to apply, you're going to attach a pressure gauge to it, and that pressure gauge will give you a reading of pressure. Okay, that's your, so let's say it's giving you 20 kilopascals. Giving you यहाँ पे pressure, that's 20 kilopascals. But that's the combined, that's known as the total pressure. So that is the total pressure of all the particles combined. That means the total pressure is the pressure that's exerted by N2, the pressure that is exerted by the H2 particles, and the pressure that's exerted by the NH3 particles as well. Okay, so that's the total pressure is the combined pressure of all the individual pressures of all the gases combined. ठीक है, ये बात भी clear है कि, so what is this clear? Munad, is this clear? Rafi, clear?
Yes.
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 So now the next thing is, how do you figure out the individual pressures? Like, because to find KP, I don't want the total pressure. I want the individual pressure of all the gases. So what I'll do is, I'm going to assume that all particles, they exert the same force when they collide with the container, or they exert the same average force. So, well, H2 jar hai, it's going and hitting the container. It's going to exert a certain force. Yellow particle H2 jar hai, so it will exert a certain force, right? So all of them exert the same force per unit area. So what are the total number of particles? That's the total particles, and you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I've got 17 particles, right? So how do I figure out? मुझे पता है कि 17 particles का जो combined pressure है, that's 17 particles combined exert this total pressure, which is 20 kilopascals. So what will be the pressure that will be exerted by H2 only? So proportionally, it's going to exert the same pressure. Uske moles honge, the amount of moles, it's going to be proportional to that. So out of 17 particles, how many yellow particles do you have? That's 1, 2, 3, 4, 5, and 6. So that means out of the 17 particles, there are only 6 particles of H2 into 20 kilopascals. Okay, percentage nikhal lo, like how many particles do you have? What is 6 over 17? What do you get for this? Like if you do 6 over 17, that's going to be percentage wise. How many H2 particles do you have?
Oh, percentage or decimal, sir?
The decimal is 0.35. Percentage wise is 35%, right? Like the 35% of the container is H2, right? So that means H2 will be exerting 35% of this pressure. Is that clear?
Ji sir.
So that's how, so that's this additional step that you have to do. Previously, we knew how to calculate the moles at equilibrium, right? Like we did a lot of questions on this. But there's going to be an additional step. And that additional step is you would have to do this. You'll have to figure out the fractional percentage, like H2 get particles out of the total moles. How many particles are of H2? You find out the fraction and you multiply it by the total pressure. So if it's coming out to be 35%, so H2 will be exerting 35% of the total pressure that's appearing on your pressure gauge. I say N2 का क्या होगा? What would be N2? That's okay, how many particles do we have?
Sir, N2 got 29% of it.
You get the particles, you just have 1, 2, 3, 4, 5, right? 5 was 17, right?
Ji sir.
So that means 5 out of 17 into 90% the universe. 5 or 17 is like, I mean, 30 something, right? Achha, what about NHT? That's 1, 2, 3, 4, 5, 6. Okay, so the pressure that's exerted by NH3 so the pressure that's exerted by NH3 will be 6 out of 17, right? 6, 5, and 6 is that? 12 plus 5, 17. So 6 into 20 kilopascals. Can you tell me what the value is for each one of them?
Sir, क्या वो percentage?
Then what do you get for this? Yes, for 23 multiplied. What do you get?
Sir, पहले का 7.06 है.
So the first one is 7.06 kilopascal. Remember, I'm not going to convert the unit. I'll just keep the unit as it is. दूसरे का क्या है?
5.88.
Okay, that's 5.88 kilopascals. And the third one is the same as the first one, right? 7.06.
Ji sir.
So that's 7.06. That's a kilopascal as well. So, anyways, what you've found now is you've now figured out. So what you've done is you've figured out the individual pressures of all the gases. The pressure that's exerted by H2, the pressure that's exerted by N2, and the pressure that's exerted by NH3. Is that clear?
Ji sir.
And
Yes.
and you're going to use, so this is this additional step, okay? Like in the previous case, you would find the moles at equilibrium, right? I mean, you find the moles of at equilibrium. Now you're going to do an additional step, and that's going to be this. I'll write a formula for this, but remember, you have to find the individual pressure of all the gases. They'll give you the total pressure. You'll somehow figure out the individual moles of all the gases. Or unko use karte hue, you'll find the individual pressure that's exerted by all of the gases. If you add them all together, that's going to be equal to the total pressure. Okay, pressure of N2, pressure of this is known as the partial pressure of N2. This is known as the partial pressure of NH3. Okay, so because it's not the total pressure, it's partial pressure of this, partial pressure of this, partial pressure of this. So you're going to substitute these values in your so you're going to substitute these values in your expression, which is, what was your expression? Kp is the partial pressure of NH3 squared, that's 7.06 kilopascals squared. And it's going to be divided by what? Divided by N2, which is 5.88 times H2 cubed, right? So that's 7.06, and that's going to be cubed. And we already calculated the unit for this. It's the unit was kilopascals minus 2, right? So क्या value आ रही है for this?
0.02.
0.02.
जी सर.
So it's 0.02 kilopascals minus 2. Is this clear?
जी सर.
Brad, is this clear?
Yes, sir. Yes.
So this is your extra step. So that's your extra step. And that is to calculate the partial pressures.
सर,
हाँ जी.
फिर हमने तो ये पार्टिकल्स काउंट किए, तो असल में क्वेश्चन में तो मोल्स दिए होंगे ना.
हाँ, मतलब हम पार्टिकल्स काउंट किस ना करते हैं, किस यूनिट पे काउंट करते हैं, मोल्स में ना.
जी सर.
असल में तो होगा कि 17 मोल्स टोटल पार्टिकल्स हैं, 6 मोल्स उसके हैं. ठीक है, तो रिमेंबर वो हमारा यूनिट तो काउंटिंग का मोल्स है. ठीक है.
ओके सर.
अच्छा, सो फॉर्मूला इसका देख लो पार्शियल प्रेशर का. ठीक है. सो partial pressure का जो formula है, that's if you have any reactant, right, it will be mole fraction multiplied by total, multiplied by the total pressure. ठीक है, that's what your formula is for calculating partial pressure of any reactant or product. And you don't even need moles, you need percentage से भी काम चल जाएगा. If somebody told you that this container had 20% hydrogen and 20% nitrogen and 60% NH3, will you be able to figure out the partial pressure? Well, you should be able to, right? Clear?
जी सर. जी सर.
Yes, sir.
So you don't even need moles for this. Okay, you just need the percentage of moles or the number of particles into total pressure. Okay, so for example, if you've got air around you, right? So air कितना pressure exert करती है? In total, air exerts a pressure of 1 atmosphere, right? Or 101325 pascals, right? So if somebody tells you like what pressure is exerted by N2, so 78% होगा, because 78% of the air is N2, right? So that is going to be the partial pressure of N2. That is the pressure that's exerted by N2. Is that clear?
जी सर.
And if somebody tells you like what is the pressure that's exerted by O2, that's going to be 21% of this. So you can, agar moles na bhi pata, if you know the percentage, you can just multiply the percentage with the total pressure and you will find the partial pressure. So there's an extra step, which is this one. Yeah, that's it. Otherwise everything else is kind of the same. Okay, or ये याद रखें कि this is only for gases. If you KP expressions will only be for gases. If it has any other state, that will be taken as one. But if it solid hoga, liquid hoga, that will be taken as one. So in any KP expression, the partial pressure will only be calculated for gases. And we should write this down. Any other state, so any other state then the partial pressure for that will be taken as a constant. Any other state, the partial pressure will be taken as a constant. It's going to be taken as one. You're just going to ignore it in the expression. Okay, so you're not going to write it in the expression. Because any other state, it will not affect the pressure. यानी मेरा room है ना उसके अंदर if I अगर उसमें 2 chairs पड़ी ना, if I add a third chair, it's not going to exert the pressure that the gas is applying on me. I mean, it won't do anything. ठीक है. हाँ, अगर मेरे room में ना, if you add more gas, then the pressure that's exerted on me will increase. तो solid को बढ़ाने से, liquid को बढ़ाने से, the pressure does not increase. So that's one thing. ठीक है. It only happens for gases only. So what we'll do is we'll start doing questions now for KP. ऐसे जो नहीं हुए वो पहले कर लेते हैं कि अच्छा, let's we just say with reference to reaction, can explain one advantage a higher temperature, right? Let's start name this. The question starts here. As a jump to KP. This is about the contact process. I write on the reaction. It's SO2 gas plus O2, which is also gas, in equilibrium with 2SO3, which is also gas. Anyways, what's the KP expression plotted over reactants? So it's the pressure that's exerted by SO3, and that's squared. And you're going to divide it by the pressure that's exerted by SO2, and that's going to be squared as well, multiplied by the pressure that's exerted by O2. And unit ni manga, but the unit in this case will be what is using pascals, right? So it's going to be Pascal squared divided by Pascal. So Pascal minus 1 रह जाएगा. So it's going to be Pascal squared divided by Pascal. So it's going to be Pascal minus 1. Is that clear? Or the next question. So again, writing the equation again, 2SO2 plus O2 and 2SO3. So it's saying 2 moles of sulfur dioxide and 2 moles of oxygen were put in a flask. So the initial है. So my initial are, you're adding 2 moles of this and you're adding 2 moles of this as well and 0 moles of SO3. They did not put any SO3 into the flask. And they were left to reach equilibrium. At equilibrium, the pressure in the flask was 2 times 10 power 5 and the mixture contained 1.8 moles of sulfur trioxide. The equilibrium pena, it's got 1.8 moles of. So now that's the only information that's provided for equilibrium. So what does that mean? Okay, you started off with 0. Now you've got 1.8. That means, what does that mean? It means that 1.8 got produced, right? Is that clear?
Yes, sir.
Yes. That means there must have been some forward reaction. So to produce 1.8, how much SO2 must have reacted? It's the same ratio, right? So kitna react hoga? 1.80, right?
1.8. Yes, sir.
And how much O2 would have reacted to produce 2SO3? It's 2:1.
0.9.
So yahan pe na, it's going to be 0.90. They must have reacted. So piche kitna bach gaye? You started off with 2 moles, now you 1.8 have reacted, so you're just left with 0.2 moles, right? As a
Yes.
O2, you started off with 2 moles, 0.9 are gone, so you're left with what, 1.10 moles, right? Is that clear?
Yes, sir.
Yes.
So you found your equilibrium moles. This is the situation of the container. This is the situation of the container at equilibrium. So now to find Kp, I would first need to find the partial pressure. Like, what are my total moles at equilibrium? Sano ko add up karo. Like, what do we get? Like 1.8 plus that's 3.10 moles, right? Is that clear? Is it 3.10?
3.1, yeah. 3.1, yes.
And what are these 3.1 moles? How much pressure are they in total exerting? Also, the pressure in the flask was 2 times 10 power 5. So what I need to do is I need to find the individual pressures. What's the pressure that's exerted by SO2 only? That's going to be what? Mole fraction. What is the mole fraction? That out of the 3.1 moles, SO2 only has 0.2 moles. So it's going to be 0.2 divided by 3.10 times the total pressure, which is 2 times 10 power 5. Is that clear?
Yes, sir.
I'll find the partial pressure that's due to O2. Okay, out of all these moles, O2 के moles जो है, that's 1.10. So that's 1.10 divided by 3.10 times 2 times 10 power 5. और फिर उसके निकालो the SO3 thing. 1.80. Achha, so what do we get for this?
सर पहले वाले का 1.3 into 10 power 4.
कितना है?
सर पहले का 1.3 into 10 power 4 है.
1.3 times 10 power minus 4.
10 4.
ये 1.3 है ना?
जी सर.
इसका क्या आ रहा है?
सर वो माइनस नहीं है, सिर्फ 4.
अच्छा ये 4 है प्लस 4 है. और इसका क्या है? This next one.
7.1 into 10 power 4.
7.1 times 10 power minus 4 and this one last one.
1.2 into 10 power 5.
Minus 4 like 1.2 times 10 power 5. Then put these values in the KP expression. It's going to be pressure of SO3 squared. Okay, so remember that's why it's a 5-mark question, because you got extra steps now. Pressure of SO2, that's going to be squared multiplied by the pressure of O2. Okay, is this clear? You're going to plug in all these values over here. Okay, is this clear?
Yes.
तो चलो इसका ग्रुप पे ना मुझे क्वेश्चन वो आंसर बता देना. और ठीक है, next class में tomorrow we'll do more questions on this on KP.
सर इसका आंसर 1.12 into 10 power -3 आ रहा है.
1.12. अच्छा, you have to be very careful with your calculators. ठीक है? -3, -5.
-3.
अच्छा, so you have to be very careful with your calculators over here. ठीक है? Every calculation has to be carefully done. बस ठीक है, इसको डबल चेक कर लेना. We'll try and do more questions. इसको सेव करना है. अच्छा, we'll try and do more questions in the next class. ठीक है?
ओके सर. सर ये 19 सितंबर की वो रिकॉर्डिंग भेजनी है और ये वाली भी.
ठीक है, मैं देखता हूँ उसमें अपलोड हुई है. मैं करता हूँ.
ओके सर. अल्लाह हाफिज़.
ओके, अल्लाह हाफिज़.
Okay, thank you, sir.